Today we are going to discuss 2016 A levels, Pure Maths Part B, question number 11. This is the essay paper. So the top part is quadratics, and the bottom part is going to be from polynomial, specifically remainder theorem and factor theorem. Okay, we'll discuss this. Question number 11A. Read the question. They are telling you that let A, B, and C be elements of real numbers such that A is not equals to 0 and A plus B plus C is not equals to 0. Let fx equals to ax squared plus bx plus c. They are asking you show that 1 is not a root of equation fx equals 0. Okay, we have to show that 1 is not a root. Okay, so we'll assume so what will happen when 1 is the root? What will happen if 1 is the root? Okay, that's the question you must ask. Okay, if 1 is the root, you can put f1. What is the value of f1? A times a is 1 squared plus b times 1 plus c. That is a plus b plus c. f1 is equal to a plus b plus c. Okay, the equation is fx equals 0. But we know that a plus b plus c cannot be 0, which means f1 cannot be 0. Therefore, what we can conclude by this is that 1 is not a root of the equation fx equals 0. First part done. Now they are telling let alpha and beta be the roots of the equation fx equals 0. So you have ax squared plus bx plus c equals 0. The roots are alpha and beta, which means alpha plus beta is minus b over a, alpha beta is c over a. Okay. They are asking show that alpha minus 1 beta minus 1 is 1 over a plus b plus c. Okay, then alpha minus 1 beta minus 1, sorry, alpha minus 1 beta minus 1. Okay, this is alpha beta minus beta plus 1. Alpha beta, take minus alpha minus out, alpha plus beta plus 1. Alpha beta here is equals to c over a minus b over a, so b over a plus 1. So this is going to be c plus b plus a over a, that is 1 over a plus b plus c. It is alpha minus 1 beta minus 1. Okay, then they are asking you the quadratic equation with 1 over alpha minus 1 and 1 over beta minus 1 as the roots. Okay, so they are telling you that there is something called as gx equals 0, and that gx equals 0, they have gx equals 0, and this gx equals 0 has two roots, that is 1 over alpha minus 1 and 1 over beta minus 1. So they are asking us to prove that gx is something, they are giving you gx also. Okay, so the equation, the roots of the new equation, that is 1 over alpha minus 1 and 1 over beta minus 1. Okay, so the sum of this, what will you get? The sum of this 1 over alpha minus 1 plus 1 over beta minus 1. If you consider the sum, it's going to be alpha minus 1 beta minus 1 cross multiply. So here beta minus 1 plus alpha minus 1. So you have alpha plus beta minus 2, alpha minus 1 beta minus 1. But we already know that we have found that alpha minus 1 beta minus 1 is 1 over a plus b plus c. So alpha plus beta is minus b over a minus 2, okay, divided by 1 over a plus b plus c. So this is minus b minus 2a, okay, 1 over a will be outside, over 1 over a plus b plus c. 1 over a, 1 over a cancel off. You can take minus out if you want. So if I take minus out, it's minus 2a plus b, a plus b plus c. What about the product? The product is 1 over alpha minus 1 multiplied by 1 over beta minus 1. That is 1 over alpha minus 1 beta minus 1. So alpha minus 1 beta minus 1 is this. So if you consider the reciprocal of this, it's going to be a over alpha a plus b plus c. Now this is okay. Now the equation with roots 1 over alpha minus 1 plus 1 over beta minus 1 is always going to be x squared minus the sum of roots plus product of roots equals 0. Okay, so we have x squared minus minus becomes plus 2a plus b over a plus b plus c plus a over a plus b plus c equals 0. Cross multiply a plus b plus c x squared plus 2a plus b, you have to put an x here, x plus a equals to 0. So this is the equation they have given us. We have got that equation perfectly. Okay. Now for the next part, they are telling you that let a is greater than 0 and a plus b plus c is greater than 0. Okay. They are telling show that the minimum value m1 of fx is given by m1 over minus delta over 4a. They are giving you delta equals b squared minus 4ac. So they are giving you delta equals b squared minus 4ac. Okay, this is a show that question. So m1 equals fx minimum value, the minimum value of fx. Okay, so then if you consider the minimum value of fx is m1, so if you consider fx is actually ax squared plus bx plus c. If you take this a out, x squared plus b over ax plus c over a, you can complete square this, x plus b over 2a whole thing squared minus b squared over 4a squared plus c over a x plus b over 2a squared. Now if you simplify this, you have c over a minus b squared over 4a squared. That is common denominator 4a squared. So you multiply this by 4a, multiply this by 4a. 4ac minus b squared, take minus out, b squared minus 4ac over 4a squared. So instead of this, you can write minus b squared minus 4ac over 4a squared, not 2a, 4a squared. Now if you put a inside, a times x plus b over 2a squared minus, I'll put delta over 4a. Why? Because this a, if you multiply by this term, a and a cancel off. Okay, so I'll erase this part. Then fx minimum, now fx is a quadratic graph, no, so quadratic graph fx is a minimum. Why? Because coefficient of a is greater, therefore fx is a minimum graph. So the minimum point, if you consider, it looks like this will be the turning point. Okay, at the turning point only minimum point will happen. So minimum point is the y coordinate of the turning point. So turning point happens when this bracket part becomes 0, x plus b over 2a equals to 0. Okay, at that point fx is minus delta over 4a, therefore we can say m1, which is fx minimum, equals to minus delta over 4a. Okay, basically at this turning point you have the minimum point. Turning point happens when this part becomes 0. When this part becomes 0, this will be what? the minimum point. Very easy. Next. Okay, now they are giving you that. Now they are giving you that m2 equals to the minimum value of gx. M2 is the minimum value of gx. Okay, so first of all, let's find what is m2. So when you consider m1 is minus delta over 4a. Now this happened when fx equals ax squared plus bx plus c. It's actually minus b squared minus 4ac over 4a. Now if you consider m2, that is based on gx, where gx is a plus b plus cx squared plus um, a plus b plus cx squared plus 2a plus bx plus a. Okay, now here b squared means out of fx, which means if you consider the same pattern, m2 is equals to minus, wherever you have b squared you can put 2a plus b squared minus 4a plus b plus c, okay, times a. Put a square bracket here, divided by 4 times a. Here a is a plus b plus c. Now this a comes because of this a, which means whatever that comes here should be taken to this. Now you can simplify this, minus open brackets 4a squared plus b squared plus 4ab minus 4a squared minus 4ab minus 4ac divided by 4a plus b plus c. This is m2. 4a and minus 4a cancel off, 4ab minus 4ab cancel off, m2 is minus b squared minus 4ac divided by 4 times a plus b plus c. m2 is actually minus delta divided by 4a plus b plus c. m1 is minus delta divided by 4a. So if I divide one by the other, if I consider this as 1 and this as 2, if I divide one by the other, I'm getting m2 divided by m1 equals to minus delta over 4a plus b plus c divided by minus delta over 4a. 4 cancel off, minus delta cancel off. Okay. Now m2 over m1 equals to 1 over a plus b plus c over 1 over a. Cross multiply 1 over a m2 equals 1 over a plus b plus c m1. Okay, again cross multiply a plus b plus c m2 equals a m1. True. This is what they are asking you. Hence, now using this, show that fx is greater than 0 for all x is real number if and only if gx is greater than 0. Okay, now this is for all x is a real number. Now if you consider the graph fx, this is fx. If you want this fx to be positive, this is what a positive fx will look like. Fx is positive or equals to 0. We can have it on the x-axis also, no problem. Either this is correct or this is also correct. Both are okay. Both are okay. Okay. But whatever happens, you have to remember that this point here, this fx minimum point also is above this. Here fx minimum point is equals to 0. So if you want this fx to be greater than or equals to 0, the minimum point should always be on this line x-axis or above this line x-axis, which means it looks like this. Fx will be greater than 0 if and only if fx is greater than fx minimum, which is equals to m1 being greater than or equals to 0. Okay. Now m1, we can write it as this. m1 is actually, if you subject m1 here, a plus b plus c divided by a, m2 is greater than or equals to 0. Okay. Now this implies that, wait, we have a small amount of working to do. Now a plus b plus c is positive, they have given you this, the data, a is positive in the question itself. If this is positive, this is positive, that means that a plus b plus c divided by a, this whole thing is positive, which means m2 must be, therefore m2 must be positive or equals to 0. Okay, so you can say that this implies m2 is positive or equals to 0. Okay, so you can now write fx is positive or equals to 0 if and only if m1 is positive or equals to 0, and this happens, this is equals to if and only if m2 is positive or equals to 0, and m2 is positive or equals to 0 if and only if gx is positive or equals to 0, because gx, if you consider, this is gx and this is m2, if it is positive or equals to 0, definitely gx will be positive or equals to 0, which means fx is greater than 0 if and only if gx is greater than 0, and this works for all x is a real number. Finished. Part B. Okay, now we are going for part B. Let px equals x to the power 3 plus 2x to the power 2 plus 3x minus 1, and qx be x to the power 2 plus 3x plus 6. Using the remainder theorem, find the remainder when px is divided by x minus 1. So they are telling you by remainder theorem. Okay, we have to find p1, x minus 1, so p1. P1 is 1 to the power 3 plus 2 times 1 to the power 2 plus 3 times 1 minus 1. 2 plus 3 minus 1, 5. P1 equals 5. By remainder theorem, when Px is divided by x minus 1, the remainder is 5. Okay, then they are asking find the remainder when Qx is divided by 2. Qx is divided by x minus 2. Then Q2 equals to 2 to the power 2 plus 3 times 2 plus 6. That is 4 plus 6 plus 6. 6, 6, 6, 4, 10, 10, 16. 16. Okay. Therefore, you have to write the same thing. By remainder theorem, when Qx is divided by x minus 2, the remainder is 16. The next part of the question they are asking, okay, verify that px equals x minus 1 qx plus 5. Okay, so we'll do the long division. If you consider px, and if you divide it by x minus 1, okay, here you have x to the power 2, so x to the power 2 is x to the power 3 minus x to the power 2, 2 plus 1, 3x squared plus 3x minus 1 plus 3x, 3x squared minus 3x, you will have 6x minus 1 plus 6, 6x minus 6. So minus 6 will become plus 6, plus 6 minus 1 is 5. Okay, so this is the quotient. This is the divisor. Sorry, dividend, not divisor. This is the divisor. And this is the remainder. Okay, so you can write the px thing as x minus 1. Now if you consider this quotient is actually equals to qx, similar. So qx plus 5, verified. Okay, next part they are telling you something interesting. They are telling you that find the remainder when px is divided by x minus 1, x minus 2. Okay, now we know that px equals x minus 1 qx plus 5, and we know that qx, okay, qx is x to the power 2 plus 3x plus 6. Now if you consider qx, and if you divide this by x minus 2, you will get x squared minus 2x. 3 plus 2 is 5, x plus 6 plus 5, 5x minus 10. Okay, so this will become plus 16. So you can write qx as x minus 2, x plus 5 plus 16. Now if you consider this as equation Roman 1 and this as equation Roman 2, we can substitute Roman 2 in Roman 1. You will get px. Wherever you have x qx, you can put this. So this plus 16, this is qx plus 5. Now open brackets, x minus 1, x minus 2, x plus 5 plus 16, x minus 1 plus 5. Okay, then this is the dividend. They are telling px is divided by this. So this is the divisor. This is the quotient. We don't really care about the quotient, and this is the most important part we want, remainder. So the remainder is 16x minus 16 plus 5, that is 16x minus 11 is the answer. Okay, then we are done with the 2020 sorry 20 2016 A levels.